What does a planet look like when it stops resembling an idea and becomes a warning? For most of human history, the night sky offered only points of light. We gave them names, traced myths between them, and imagined that somewhere beyond our reach there might be other worlds not so different from our own. Maybe oceans under another sun. Maybe weather, mountains, seasons. Maybe, in some distant way, a reflection of ourselves. It was a hopeful instinct and a deeply human one. We have always looked outward by borrowing the language of home, but the universe does not share our preferences. In the last few decades, astronomers have found planets that seem less like places and more like thought experiments written by nature itself. Worlds where glass may move through the air like weather. Worlds stretched by gravity until they begin to come apart. Worlds so dark they swallow almost every trace of light, and others so hot that even the chemistry we trust begins to fail. These are not distant versions of Earth. They are reminders that reality is often stranger than imagination and far less concerned with familiarity. Each discovery began the same way: a faint dimming, a subtle wobble, a whisper in data. Nothing dramatic, no cosmic fanfare, just careful observation, patient mathematics, and the willingness to believe that a tiny irregularity might be a doorway. And behind those doorways, astronomers found not one kind of planet, but a gallery of extremes. This is the story of those worlds, not as curiosities to be feared, but as mirrors held up to our assumptions. Because every time we discover a planet that should not exist, we learn something unsettling and beautiful. The universe is wider than our habits of thought, and wonder begins the moment certainty gives way. What if the most beautiful world we found was also one of the most violent? Imagine a planet the color of memory itself, deep blue, calm at first glance, the shade of Earth as seen from a great distance, where oceans seem to gather light and hold it gently. When astronomers first studied HD 189733b, that color seemed almost comforting, as if the cosmos had briefly offered something familiar. But familiarity can be a trick of distance. HD 189733e is not a world of water and quiet horizons. It is a gas giant, large and hostile, circling its star so closely that its atmosphere is heated to extremes beyond ordinary weather. The blue glow does not come from seas. It comes from silicate particles suspended high in the air, tiny fragments of material that scatter light in a way that mimics serenity. What looks like a peaceful oceanic world is, in truth, a furnace wrapped in illusion. And the winds there do not move as winds do on Earth. They race across the planet at thousands of miles an hour, faster than sound, carrying heat, pressure, and violence in a constant planetary storm. In that superheated atmosphere, silicates can condense into glass, not solid panes or shining crystals, but sharp, burning particles driven sideways through the air with relentless force. On this world, even rain becomes a form of abrasion. There is something almost poetic about that deception. From far away, the planet appears gentle, even inviting. Up close, it is unlivable in every sense we understand. It asks us to confront an old human habit, the tendency to mistake beauty for safety, resemblance for kinship. Perhaps that is why this planet lingers in the imagination. Not because it is merely strange, but because it reveals how easily our minds reach for the known. In the end, HD 199733b is not a failed Earth. It is a reminder that the universe can wear familiar colors while speaking an entirely foreign language. What if a planet could carry night to its absolute limit? There is a kind of darkness we know on Earth, the darkness of a rural road after midnight, the darkness beneath the ocean, where light thins and disappears, the darkness of a room with the curtains drawn, where shape becomes guesswork. But somewhere far beyond our sky, astronomers found a world that seems to deepen that idea into something almost philosophical. That planet is known as TREE-S2b, a gas giant orbiting close to its star. By all logic, such a world should shine with reflected light. It should catch something, return something, offer at least a trace of brightness to the instruments watching from afar. Instead, it absorbs nearly everything. Less a mirror than a void, it reflects so little light that it has often been described as darker than coal, darker than black paint, darker than most things we can easily compare it to. If it floated near us in space, it might seem less like a planet than a missing piece of the sky. And yet, it is not invisible. It glows faintly with its own heat, a dim red ember in the dark, because it lives so close to its star that its atmosphere is intensely hot. That contrast is what makes it so unsettling. It is scorched, but not bright, present, but almost refusing to be seen. Why a planet would behave this way is a scientific puzzle shaped by chemistry and atmosphere. High temperatures may strip away the reflective clouds we expect. Light-absorbing gases may swallow what would otherwise scatter back into space. The result is a world that challenges a quiet assumption that existence announces itself. There is something deeply human in that lesson. We often imagine discovery as illumination, as bringing hidden things into the light. But some truths are found not because they shine, but because they bend the pattern around them. TREE-S2b reminds us that mystery is not always radiant. Sometimes it appears as absence, and asks whether we are capable of noticing what does not want to glow. What if a planet could outrun the logic of how planets are supposed to survive? In a universe governed by gravity, distance is a kind of mercy. Worlds that circle too close to their stars are expected to pay a price. Their atmospheres swell, their chemistry unravels, and over long stretches of time, the star begins to take back what it once allowed to form. That is why WASP-12b feels less like a stable planet and more like a moment caught just before disappearance. It is a giant world orbiting so near its star that a full year there lasts little more than a day. The star looms overhead not as a distant sun, but as a force pressed almost against the planet's skin. Heat floods the atmosphere. Gravity stretches the planet into a distorted shape, pulling it away from the simple roundness we associate with worlds. It is not merely hot, it is under stress, as if existence itself has become a form of strain. Astronomers believe this world is being slowly consumed. Its outer layers appear to spill outward, drawn by the star's gravity in a process that resembles a celestial tide turned fatal. The planet is not exploding. It is being thinned, drained, undone molecule by molecule. What we are witnessing may be less a stable object than a long farewell written in gas and light. And still, there is grandeur in that ending. WASP-12b reveals that planets are not fixed monuments. They are participants in ongoing relationships with their stars, shaped by attraction, violence, and time. Even in the sky, closeness can become too much to bear. Perhaps that is why this world feels strangely intimate. It turns orbital mechanics into something almost emotional. A story about nearness, about surrender, about the fine line between belonging to something and being consumed by it. In studying a planet that may not last, we are reminded that the universe is not built only from permanence. It is also built from fragile arrangements, brief survivals, and the quiet dignity of things that shine while they are vanishing. What if a planet was so hot that even iron could no longer remember it was meant to be solid? Far from Earth, under a star that never grants relief, there exists a world called Kelt 9b. To call it a planet almost feels insufficient. It is a gas giant, yes, but one pushed so far beyond ordinary conditions that the familiar categories of weather, atmosphere, and matter begin to loosen. This is not merely a hot world. It is a world living at the edge of disintegration. Its star is massive and brilliant, and Kelvin 9b circles it at a distance so small that the planet is blasted by radiation with astonishing intensity. Daytime temperatures climb high enough to break apart molecules and strip atoms into a state closer to that of a star than a conventional planet. In that inferno, metals do not behave as we expect. Elements such as iron can exist in vapor form, drifting through the atmosphere like the ghost of something once solid. And yet the planet endures, if enduring is the right word. One side faces the star in relentless exposure, while the other turns away into a cooler darkness. Between them, heat is redistributed by fierce atmospheric motion, creating a planet defined not by calm cycles, but by extremes locked in permanent negotiation. Kelt 9b is a place where the boundary between planet and furnace becomes uncomfortably thin. What makes this world so compelling is not only its violence, but its contradiction. We tend to think of planets as destinations, as places where matter settles into landscapes and skies. Kelt 9b refuses that image. It is not a resting place. It is a process, an ongoing chemical emergency written across an orbit. In that sense, it offers a humbling insight. The universe does not arrange itself around human-scale ideas of balance. Some worlds are not made for seas or stone or life, but for testing the outer limits of what a world can be. And in meeting a planet that burns with almost stellar intensity, we are forced to ask whether our definition of a planet was ever broad enough to contain reality at all. What if a planet carried fire on one side and weathered night on the other, never allowed the mercy of turning away? Some worlds move through time the way Earth does, rotating in rhythm, sharing sunlight across their surfaces, passing through day and night like breath. But not all planets are given that balance. Co-Rho-T 7b appears to be locked in place, one face turned forever toward its star, the other held in permanent darkness. It is a world divided not by continents or oceans, but by fate. On the day side, temperatures rise to such punishing levels that rock itself may melt. The ground is thought to glow beneath a relentless sky, not unlike a sea of lava stretching toward a horizon that never cools. There are no familiar seasons here, no soft transitions, only constant exposure. The star hangs overhead like an unblinking eye, and the surface beneath it may exist in a state between landscape and liquid. But the far side tells another story. There, in the endless absence of direct light, temperatures plunge. The same planet that burns on one face may harden into cold darkness on the other, becoming a study in extremes held within a single body. Between those halves may lie a narrow boundary, a twilight line where heat and shadow meet in uneasy tension. If there is motion in such a place, it is not gentle. It is the movement of survival between impossible conditions. For scientists, Rho-T 7b matters because it may be one of the first rocky exoplanets ever identified, a milestone in the search for worlds beyond our own. Yet the more closely we imagine it, the less it resembles a second Earth, and the more it becomes something stranger. a rocky planet stripped of comfort, reduced to elemental contrast. There is a quiet lesson in that. We often speak of discovery as if finding another world means finding another version of home. But some discoveries do the opposite. They remind us how rare balance may be, how unusual it is for a world to rotate through light and darkness without being claimed by either. And perhaps that is part of what makes Earth precious. Not that it exists, but that it lives in motion between extremes. What if a planet could be lighter than it has any right to be? In our imagination, a giant planet should feel dense with consequence. Something massive enough to rival Jupiter ought to carry weight not only in gravity, but in presence. And yet the universe has offered worlds that seem to defy that intuition. Among them is Kepler 51b, a planet so swollen and diffuse that it appears almost improbable, as though it were built from atmosphere more than substance. It is enormous in size, but astonishingly low in density. If placed beside the gas giants of our own solar system, it would look oversized, almost inflated, while containing far less material than its volume suggests. Astronomers have described worlds like this as superpuffs, and the name fits. Kepler 51b seems less like a compact planet and more like a sphere of haze barely holding itself together, wrapped in layers of gas that stretch far beyond what we would normally expect. That raises an unsettling question. How does such a world endure? Around its star, radiation should gradually strip away those outer layers. Time should press it towards something smaller, tighter, more ordinary. And yet for now, at least, it remains in this ghostly state, a planet that seems caught in an early chapter of its existence, before age and exposure can finish shaping it. There is a tenderness to that image. We are used to admiring what is solid, what is compressed by pressure into strength. Kepler 51b suggests another kind of reality, one in which fragility can also persist, however briefly, on a cosmic scale. It is not a world of stone or storm or fire, but of delicacy stretched to planetary dimensions. In that sense, this strange world feels almost symbolic. It reminds us that not everything in the universe survives by becoming harder. Some things exist in vulnerable forms, temporary and astonishing, suspended between creation and loss. And perhaps wonder lives there too, not only in what endures, but in what seems far too fragile to last, and yet somehow does. What if a planet moved through space without a sunrise, without a year, without any star to call its own? We usually imagine planets as loyal companions to suns, held in graceful paths by gravity and light. Their identities seem tied to that relationship: warmth, orbit, season, rhythm. But the cosmos has revealed the possibility of lonelier worlds, planets that drift through the dark untethered, cast loose from the systems that may once have formed them. These are the wandering planets, and among the strangest ideas in astronomy is that a world can exist with no sunrise at all. Such planets may have been born in chaos. In young planetary systems, gravity does not always build gently. Giant worlds tug on one another, stars shift, orbits destabilize, and sometimes a planet is thrown outward entirely, exiled into interstellar darkness. What remains is a world without a local sun, moving through cold space where the usual markers of planetary life, day, year, sky, lose their meaning. And still, even a rogue planet may not be entirely dead. Beneath a frozen surface, internal heat from radioactive decay or residual formation energy could linger. A thick atmosphere, if retained, might trap warmth. Some scientists have even imagined hidden oceans under ice, places sealed from starlight, yet not wholly beyond chemistry, motion, or time. It is a radical thought that a planet need not orbit a star to remain a world in motion. There is something haunting in that possibility. A drifting planet feels like a cosmic orphan, separated from the source we assume gives meaning to place. Yet it also expands our sense of what belonging is. Perhaps a world does not need to be centered in a system to matter. Perhaps existence itself is enough. In the end, these dark wanderers challenge one of our oldest assumptions, that light is the only stage on which reality unfolds. They suggest that even far from warmth, far from order, something can continue, not brightly, not visibly, but quietly in the deep, carrying its own hidden story through the night between stars. What if a planet's greatest mystery was not its heat or darkness, but the simple question of whether it should exist at all? For a long time, our solar system taught us a quiet rule. Small rocky worlds belonged close to the sun. Giant planets, swollen with gas and ice, formed far away in the colder reaches where such materials could gather. It was a pattern that felt almost elegant. Then, astronomers began finding hot Jupiters, enormous gas giants circling perilously close to their stars. And that elegance gave way to a deeper, more complicated truth. Among the most revealing of these worlds was 51 Pegasi b, the first planet discovered around a sun-like star. Its existence was not merely a surprise, it was a disruption. Here was a giant planet completing an orbit in just a few days, hugging its star in a region where older models suggested such a world could not have formed. The discovery did more than add one planet to a catalogue. It forced astronomy to reconsider how planetary systems are built and how much migration, upheaval, and instability may shape them after birth. That idea changed everything. A planet, it turned out, might not remain where it begins. It could move inward through interactions with gas, dust, or neighboring worlds, rearranging an entire system as it traveled. In that motion, smaller planets might be scattered, swallowed, or prevented from forming at all. A single giant too close to its star became evidence that planetary history could be turbulent, even violent, rather than neat and orderly. There is a lesson in that first shock. We often trust our local experience more than we realize. We take one example, our own system, our own history, and quietly mistake it for a rule. But 51 Pegasi b arrived like a correction written in starlight. It reminded us that nature is not obligated to repeat the pattern that made us, and perhaps that is the deeper wonder. The first strange planet did not just reveal a new world, it revealed how narrow our expectations had been, and how much of discovery begins with the humility to let the universe be less familiar than home. What if a planet circled not one sun, but two, learning to belong in a sky with no single center? For generations, binary stars lived mostly in the language of fiction. Two suns rising over one horizon felt like the kind of image created for myth, not measurement. Our own solar system had trained us to expect one star, one anchor, one source of light around which everything else found its place. But then astronomers discovered planets orbiting double stars, and suddenly the imagined became real. One of the most evocative examples is Kepler 16b, a world moving around a pair of stars, locked in their own gravitational dance. It does not orbit one and ignore the other. Instead, it circles both, tracing a wider path around their shared center of mass. From the surface, if such a gas giant had a surface to stand on, the sky would never obey the simple rhythms we know. Light would shift in layered patterns. Shadows would behave differently. Day itself would feel less like a single event than a negotiation between two moving suns. Scientifically, these planets matter because they prove that planetary systems can emerge and remain stable even under more complicated conditions than we once imagined. Gravity here is not absent, but crowded. The growing planet must survive a young environment shaped by competing pulls, changing illumination, and orbital complexity. And yet somehow, order still emerges. A world still forms. A path still holds. There is something quietly reassuring in that. We often think stability requires simplicity, that harmony comes only when there is one clear center around which everything else can turn. But circumbinary planets suggest another possibility. Even in systems with multiple influences, shifting forces, and no single dominant rhythm, coherence is still possible. Perhaps that is why these worlds resonate beyond astronomy. They remind us that life, too, is often lived under more than one sun, more than one loyalty, memory, grief, or hope. And still, we move forward, finding patterns inside complexity. Kepler 16b does not offer a familiar sky. It offers something better, proof that even in a universe of divided light, a world can still find its orbit. What if the strangest planet was the one that seemed, for a moment, almost possible for us? Among the many violent, scorched, and improbable worlds beyond our solar system, there are a few that attract a different kind of attention. Not because they are gentle exactly, but because they seem to hover near the edge of habitability, near the line where imagination begins to whisper about life. Kepler 22b became one of those planets, a world larger than Earth, orbiting within the habitable zone of its star, where temperatures might allow liquid water under the right conditions. That small phrase, under the right conditions, carries enormous weight. We do not know whether Kepler 22b has oceans, continents, clouds, or a crushing atmosphere that would make its surface unreachable. We do not know whether it is rocky, ocean-covered, or wrapped in thick gases unlike anything we call breathable. What we know is more modest, and in its own way, more powerful. A planet can exist in a region where warmth is possible without becoming a furnace, where distance from a star may allow stability instead of ruin. In the long catalogue of extremes, that alone feels almost miraculous. And yet uncertainty remains the defining feature. A world in the habitable zone is not the same as a habitable world. We are confronted here by one of science's most important disciplines, the refusal to let hope outrun evidence. The planet invites speculation, but careful speculation, grounded in what can be measured and what must still remain unknown. There is beauty in that restraint. Kepler 22b matters not because it confirms we are not alone, but because it keeps the question alive in a credible way. It stands as a threshold planet, one that widens the search without pretending to finish it. Perhaps that is why such worlds hold us so deeply. They are not promises, they are openings. They remind us that wonder is not only found in the bizarre or catastrophic, but also in the quiet possibility that somewhere, under a different sky, the conditions for balance may have emerged again. And if that is true, then the universe may be strange not only in its extremes, but in its capacity to make room for something like home. What if a planet could remember the childhood of a solar system better than the star it circles? Some worlds are strange because they are violent. Others are strange because they seem unfinished, as if they preserve an earlier draft of planetary history. GJ 1214b belongs to that second category. It is larger than Earth, but smaller than Neptune, part of a class of planets our own solar system does not clearly possess. That alone makes it important. It occupies a middle ground we did not know how to imagine until the universe insisted on it. Astronomers have long tried to understand what such a world is made of. Is it a rocky planet with a deep atmosphere? A water-rich world covered by layers of hot, dense vapor? A small gas planet wrapped in thick clouds that conceal whatever lies below? Observations have hinted at haze, at muted spectra, at an atmosphere unwilling to reveal itself easily. Again and again, the planet offers data, but not a simple confession. That uncertainty is more than a technical frustration. It tells us that planetary diversity may be broader than the tidy categories we inherited from our own neighborhood. Earth, Jupiter, Neptune, these names once felt like templates, but GJ1214b suggests that nature is comfortable building worlds between those examples, mixing qualities in ways that do not align with our first instincts. It may be a water world, or something close to one, though not the romantic ocean planet of fiction. More likely, it is a place of pressure, heat, and concealed depth, where familiar substances behave in unfamiliar forms. There is something moving about a planet that resists being neatly classified. We live by naming things, by sorting them into kinds, by trusting that understanding begins with categories. Yet some discoveries mature us by remaining partly unresolved. GJ1214b reminds us that knowledge is not always a matter of forcing clarity. Sometimes it is the patient recognition that reality is under no obligation to simplify itself for us. And perhaps that is its deeper gift. In a universe filled with worlds, some will not fit the stories we started with. They will ask us to make room for ambiguity, for hybrids, for possibilities that sit between the known and the unnamed. And in doing so, they teach us that discovery is not only the finding of answers, but the widening of the questions we are able to ask. What if, after all the fire, darkness, pressure, and strangeness, the real discovery was not out there at all, but here, in the way these worlds change the people who study them? Every strange planet begins as a small disturbance. A star dims by a fraction. A spectrum shifts. A pattern appears in numbers before it appears in imagination. Long before the public sees an artist's rendering of a blue world, or a black one, or a planet with two suns, someone sits in front of imperfect data, asking whether the signal is real. Discovery, at first, is rarely cinematic. It is quiet, repetitive, careful, and deeply human. That may be the most surprising part of this story. We speak of distant worlds as if they arrive fully formed, carrying their mystery intact across light years. But what reaches us is far more fragile. Photons, measurements, error bars, interpretations. Between the planet and our understanding lies an entire chain of human effort. Engineers building instruments, astronomers arguing over models, teams revising conclusions, younger scientists inheriting questions that older ones could only begin. The planets are strange, yes, but so is the fact that minds evolved on one small world can detect them at all. And with each discovery, our sense of normal shifts. We no longer assume that every planetary system resembles ours, or that worlds must be solid, temperate, symmetrical, or even permanently attached to a star. The catalogue of exoplanets has become more than a list. It is a slow correction to human certainty. It teaches us that reality is more inventive than custom, and that the universe does not repeat one design simply because it happened to include us. So by the time we reach this point in the journey, the question has changed. It is no longer only what kinds of planets exist. It is also what happens to a civilization when it discovers that its home pattern is not the standard. Perhaps humility grows. Perhaps imagination becomes more disciplined and more generous. Perhaps we begin to understand that knowledge is not a wall built around certainty, but a widening circle drawn around mystery. And if that is true, then the strangest planets have already done something extraordinary. Long before we ever reach them, they have enlarged the inner universe of the species that found them. So where does this leave us after crossing a gallery of worlds made of heat, darkness, pressure, illusion, and drift? It leaves us, perhaps, with a quieter understanding of what discovery really is. We began with a simple instinct, to search the universe for something familiar. Another Earth, another sky, another place where our own story might echo back to us. But the strange planets scientists have found do not simply answer that desire, they complicate it. They remind us that the cosmos is not arranged around comfort, and that truth often arrives wearing forms we never would have chosen for it. And yet this does not make the universe colder. In a strange way, it makes it more intimate, because every one of these worlds, whether it rains burning glass, absorbs nearly all light, drifts alone between stars, or circles two suns at once, has reached us through an act of patient attention. We know them because human beings looked carefully, doubted carefully, measured carefully, and remained open to being surprised. The grandeur is not only in the planets themselves, it is also in the fragile intelligence that noticed them. That may be the deepest thread running through this journey. Strange worlds do not diminish Earth. They clarify it. By showing us how many different ways a planet can exist, they reveal how unusual balance may be, how rare a world of oceans, breathable air, turning seasons, and modest light might actually be. The farther we look, the more our own home comes into focus, not as the default model of a planet, but as one precious arrangement among countless others. So the final question is not whether the universe is stranger than we imagined. It is. The better question is what we will do with that knowledge. Will it make us cynical or reverent? Will it tempt us to reduce mystery into spectacle, or invite us into a more patient kind of wonder? Perhaps the future of discovery depends on that choice. We look outward to understand distant worlds, but in the end, every revelation returns us to ourselves, to our curiosity, our limits, our tenderness for the brief conditions that allow us to ask questions at all. And maybe that is the enduring lesson of the strangest planets ever found. That truth is often unfamiliar, wonder is often disciplined, and home is made more meaningful by the vast and beautiful strangeness that surrounds it.